Okay, in this video, we're going to be doing Calc AB Problem Set 122. The problems and a playlist are in the description below. Let's look. So the region bounded by y equals sine of x over 2 on 0 to 2 pi is split into two regions by the vertical line x equals k. If the area to the left of x equals k is twice the area to the right, find the value of k. All right, let's start with a picture. The period of sine of x over 2 is 2 pi over 1/2, so 4 pi. Which means from 0 to 2 pi, we just get like the first kind of hill, right? So here's pi, here's 2 pi, and our curve kind of looks like this. Now, the region to the left is twice the area to the right. So to the left of the line is just bigger. So I like to draw it so that it looks kind of accurate. I don't really think that's totally accurate. But from this, we can set up, if I do the integral from 0 to k of my function, what I would need to do is I would need to double the area from k to 2 pi, right? Because the area to the left is twice the area to the right. So this is our setup. Once we've set it up correctly, it's just all fundamental theorem stuff. So I'm going to find an antiderivative. There should have been a 1/2, so a 2, and then you get negative cosine. So negative 2 cosine of x over 2 from 0 to k. There's already a 2, so when we multiply by the 2, this time we get negative 4. But same antiderivative. Okay, so now fundamental theorem on this thing. Also, I've divided by negative 2 because it's just annoying that they're both times negative 2 at this point. So I get this. So just to be clear, it's like I divided both sides by negative 2, give me a 1 on the left, it gave me a positive 2 on the right. That's where that 2 is coming from. Okay, so now we just think about what is the cosine of 0 is 1. And then the cosine of pi is negative 1, and let's distribute the 2. So we'll get negative 2 minus 2 cosine of k over 2. All right, I'm going to add 2 cosine of k over 2 to both sides, and I'm going to add 1 to both sides. So I'm moving everything to kind of its own side. I get this, which means that cosine of k over 2 is negative 1/3. Now the question is that like where we need it to be? It definitely is because we can say k over 2 is the inverse cosine of negative 1/3. The inverse cosine of negative 1/3 is a quadrant 2 angle, so it's somewhere between pi over 2 and pi, which is exactly what I want. So you can do this little picture. We're somewhere over here. So I'm going to say that k is 2 inverse cosine of negative 1/3. Kind of a beast of a problem. It comes up sometimes. Probably would be calculator, to be honest. But I'm not really sure. So let's take a look at the next one. Find the area of the region enclosed by y equals square root of 15 plus 2x minus x squared from negative 3 to 1. So really our only hope on this problem is that this is a semicircle because we, at this level of calculus, don't know how to integrate this thing. So we're going to hope it's a semicircle. Let's see if we can make any progress on that. I'm going to take a negative out of everything because I'm going to have to complete the square, and I do not try to complete the square with a negative coefficient. And then, so we're going to do this, negative 2x. Take negative 2, divide by 2, that's 1. Square it, that's 1. Add and subtract, so plus 1, minus 1, and then negative 15 is still there. Clean this up a little bit. So y is negative quantity x minus 1 squared plus 16, or square root of 16 minus the quantity x minus 1 squared, if that's how you prefer. This is definitely a semicircle. It has a radius of 4, and it has a center at 1, 0. And that's really important because otherwise I don't think we'd be able to do the problem. So let's draw it. So at 1, 0, and then the radius is 4, so you can go 4 in every direction from 1, 0. We're looking to do the integral from negative 3 to 1, which is just this quarter of the full circle. So our integral is 1/4 of a circle that has a radius of 4. So 1/4 of pi r squared, 16 pi. So the answer here is going to be 4 pi. It's a pretty good question. You have to like mix geometry with some calculus knowledge. I like it. All right, let's look at the next one. Write an integral whose value, this is nice, we don't have to actually do it. Write an integral whose value gives the volume of the solid form when the region bounded by y equals x over 3 and y equals 1/6 x squared is rotated about the x-axis. You pretty much always want to start with a picture for this. So there's our line. Here's our quadratic. We're going to need to know where they intersect to be able to like set up the definite integral. So just set them equal to each other, multiply both sides by 6, move everything to one side. So I actually moved everything to the right, but then I always just rewrite it. So x squared minus 2x equals 0. Factor, I'm sure at this point you know, I don't know why I'm making you watch this. And then our intersections are 0 and 2. So those are going to be the bounds. So we're going to do pi, don't forget pi. It's going to be pi, the integral from 0 to 2. We have our big radius, which goes until it hits the linear function. So we're going to square the big radius, that's x over 3 quantity squared, minus our little radius goes until we hit the quadratic. So that's 1/6x squared, technically minus 0, but 1/6x squared squared dx. And that's all we have to do. I mean, I don't think it would have been too unreasonable to ask you to evaluate this, but I didn't, and I'm kind of thankful for that. So anyway, that's the whole problem set. I hope this was helpful, and good luck.